Hey everybody, welcome back. So yesterday you guys read some notes about atoms and the parts of the atom to start our chemistry unit. So today we are going to work on the worksheet and we're going to be doing a lot of it together. If you don't need me to do it with you, you're more than welcome to, try to work ahead, but I'm going to kind of do this with you guys. Yay. So an atom is actually made of three parts. We've got protons, we've got neutrons, and we've got electrons here. So basically, the first thing we're going to look at is the electric charge. So electricity comes from the movement of atoms. And in order for us to understand that, we need to look at what charges each part of the atom has. So a proton is actually positive charged. Okay. A neutron has no charge. All right, so we can call that neutral. Okay. And then finally, an electron has a negative charge. Right. And it's the changes that happen between these positive and negative charges that actually create the flow of electricity. Sorry, you guys. Kind of neat, right? All right, so the location in the atom. So if you look at a picture of an atom, which you guys saw in the notes yesterday, you should notice that the protons and neutrons are in the nucleus, okay, which is actually the center of the atom. Okay, so they're both in the nucleus. There we go. Now the electrons are not, and this is why we have electricity, because electrons are flowing around the center, kind of like the planets circling the sun. So if you think about how the planets move around the sun, same idea. Those electrons are flying around really, really fast, and they can move from atom to atom, and they can get flung around. And that's kind of why when we talked about static electricity, like, you know, when you rub the balloon on your head and it sticks up, all the electrons are moving around. They're getting transferred. It's really cool. So electrons are found outside the nucleus. Right? And again, you don't have to draw the picture because it's in the notes, but just so you have an idea, you have your protons and your neutrons in the middle, and then your electrons are kind of flying around the outside like that. Okay? All right, so now we're going to look at using the periodic table to tell us how many of these particles an atom has. So let's review this. So when you look at a periodic table, often it's set up this way, but they're all a little bit different, okay? So the atomic number is the number of protons. Just to remember, atomic number is always the smaller number. So you might want to write that down because when you're looking on the periodic table, it's going to be really important. There's always two numbers, and the atomic number is always the smaller one. Okay? And that tells you the number of protons. Okay? You got your chemical symbol, which is usually just one or two letters, in this case C for carbon. Your element name, in this case, is carbon. And then your atomic mass, which is the protons plus the neutrons. So this number here is the protons plus the neutrons. It's both, right? Protons and neutrons are both have mass, all right? Electrons do, but it's really tiny, right? So to find the number of protons, look at the atomic number. So we're going to do each of these, all right? So for protons, and I'm going to even circle the word protons, okay? Look at the atomic number. So our atomic number is 6. Fantastic, right? So that means 6. We have 6 protons, all right? So again, protons is equal to atomic number. All right, keep that in mind. To find the number of neutrons, and this is where it's weird, subtract the atomic number from the atomic mass, all right? So there's only two numbers here. You're going to subtract them, okay? Very simple. So 12 minus 6. I am going to round this number to 12, okay? Because it makes it a lot easier. You are welcome to round these numbers. So just keep that in mind, all right? Equals 6, all right? So the atomic mass in this case is 12, but the number of neutrons is 6. 6 neutrons, all right? So you subtract them. To find the number of electrons, look at the atomic number. So the cool thing is electrons are equal to protons, all right? So protons equal electrons. All right, and the reason for this is because protons are positive and electrons are negative. So they have to be equal to each other. Otherwise, you're going to have a charge, and that's not going to be good for us. Alrighty. Now let's try the second page. Okay. Here we go. This chart might look a little overwhelming. Don't worry, it's actually really easy. So it goes in order of atomic number. So when you look at the periodic table, you're going to look at only those first 10 elements, okay? So our first element on the periodic table is hydrogen. All right. Atomic number 1. The atomic mass written on the table is actually 1.0, I think it's 001. It's a very small number. It's 1.0. All right. Now to find the protons, remember we just look at the atomic number. And if you want to make a note up here, do it. So protons is atomic number. I'm going to use the symbol for number. Okay. Electrons is also atomic number. All right. So these two should be the exact same as this number. So atomic number is 1. That means you have 1 proton and 1 electron. Okay? 1 and 1. Now, if we look for the neutrons, it's the atomic mass, all right, minus the atomic number. So in this case, it's 1 minus 1. You can round this, okay? Which is what? 0. Excellent. All right. So in this case, a normal hydrogen atom has 0 neutrons. Whoa, cool, right? All right. I'm going to go down to a different one, so I'm not doing all these in a row. So let's try number 5. So I look up on the periodic table. I find element number 5. Okay. I'm going to notice that it's boron. Okay. And the symbol's B. If you want to put it on there too, you can. So the atomic mass of boron is 10.8. Right? Which, again, you can round to 11. I'm just going to put 11 there in parentheses. So you can round that to 11, okay, to make your math easier. So protons, all right, is equal to the atomic number. Should be 5. Electrons should also be 5. Remember that these two should always be equal, okay? Proton and electron are equal to each other, positive and negative, okay? Now, finally, for neutrons, we're going to subtract. And I'm going to do it in the box, all right? And I'd like you to do this, too, so that you remember how to do this, okay? You're going to have to do this with me as an 11th grader when you take chemistry. So kind of exciting. Woohoo! So we're going to do 11 minus 5 equals 6, all right? So this is your answer, 6 neutrons. Sweet, right? That is not too bad. So you're going to fill in the rest of these elements. Again, you're only looking at that first 10. And if you're struggling with this, please send me an email or make a comment, and I will do a couple more examples for you. So just want to make sure everybody's got this. And I hope you guys have an awesome weekend. Cheers.